10.5, areas of parallelograms and triangles. So we actually already did this, but now this is going to get a little bit more difficult. So let's take it back. We have area of regular polygons, and we know that that area is equal to 1/2 times the apothem times the perimeter. We know that from 10.3. So what if I gave you a shape like this? And we don't have the height, okay? We need to figure out what the height is. Before you can do anything, you have to figure out that height. Remember that height that creates a 90-degree angle. So one thing we have to do is actually figure out what this angle right here is first. So once we have the center of a polygon, the first thing we want to do is find that central angle. When we're looking at this central angle, we have, remember from 10.3, one circle is 360. So we can always do 360 divided by how many sides we have. In this case, it would be 360 divided by 6, which would be equal to 60 degrees. That apothem, remember, always cuts that in half. So if I want to cut that in half, now I can do this also cuts it in half. So if this is 60, this angle right here is 30. That's going to help us. Okay, we want to be able to do this step every time. So let's go back to looking at this. Now this is looking at this picture right here. So remember, we can do the 360 divided by how many sides? So if we did that first, if here I drew up my triangle right there, this is 7.5, just like how this problem up here has it. If I found my central angle is 45, and we found this apothem, because it's 45 because it says 8 sides. If you didn't count them, these are 8 sides. So I'd have to do 360 divided by 8 to get 45. Now if I draw my A, and the second one, if I draw my A, that creates my 90 degrees. Remember, your apothem is always from your center to the edge, making this cut in half. So now I have this 22.5. Where did that come from? My central angle cut in half. So 45 divided by 2 is 22.5. Once you draw that apothem, that also cuts this whole side length in half. So 7.5 divided by 2, that's this 3.75. Now we have enough information. You will often hear me say in this 10.5 section, to draw your right triangle. Your apothem always helps create your apothem. This length is always half a side length, and this angle is always half the central angle. I will always be referencing back to this triangle. Now to figure out my apothem, I have to use SOHCAHTOA. So when I'm looking at SOHCAHTOA, here's the angle that I have. I have my opposite. I'm looking for my adjacent. So that's TOA. Remember, the T stands for my trig function. So in this case, it's tan of my angle is equal to my opposite over my adjacent. Always first step. No matter what, your first step is always to get rid of this division. The opposite of dividing, I'm saying divide by A, so I'm going to multiply both sides by A. So A times tan of 22.5, that's point, is equal to 3.75. Remember, this is just some number. That's some number that is long and is in a decimal. So I have to divide by tan of 22.5. So if I'm looking for A, this will be equal to 9.05. I want you to round to this nearest hundredth. Now, depending on how you round, your answer when I'm finding the area, because remember, my whole question is actually to find the area of this shape. So let's go back to see what we've done so far. Your first step is to find the central angle. That's what we did right here. We found the 45. Then you cut that in half so that you can figure out the apothem. So this is where I cut it in half. You always have to create that right triangle so that you can use SOHCAHTOA. So this was a right triangle. We set up our SOHCAHTOA, and now we have enough information. So now when we're actually going back, so this was to find the apothem. Now we go back to what is the question actually asking? The question is asking to find the area of the regular polygon. So my apothem here, A was equal to 9.05. My perimeter, remember, go back to the original problem. One side length is 7.5, and I have 1, 2, 3, 4, 5, 6, 7, 8. So you could do 7.5 plus 7.5 8 times, or else you could just multiply it by 8. Makes your life a little bit easier. That should not be a 0.4, that should be a 0.5. Sorry, please make that correction. So now I have my area. So going back all the way to our formula, it's 1/2 times my apothem, which is 9.05, times my perimeter, which is 60. So we have 271.5, and my units, going back up here, with centimeters and area, is always squared. So now looking at this first problem, I want you to first pause the video and try to set up, go back through your steps right here. Go back through these steps to try to set up your right triangle. Do that, pause the video and try to do that by yourself right now. So now this is what your right triangle should look like. Remember, there are 9 sides. Notice how I counted up the number of sides and I got 9. So if you do 360 divided by 9, my central angle, remember the central angle looks like this, from the center to the 2 vertices, that's your central angle is 40. Now I take that and divide it by 2 because now I'm looking at my apothem. I'm cutting that angle in half. So that's where that 20 comes from. When you create that apothem, now you're cutting the side length in half. So I'm taking 10 and dividing by 2. So now I want you to pause the video and find your apothem. Right now, using SOHCAHTOA, review from chapter 8, find the apothem. So you should have got your apothem to be 13.74. Again, I want you to round to the nearest hundredth. So you're using tan because you have your opposite looking for your apothem. Now, a lot of times people ask me, is it always going to be tan? Very similar unless the radius is given, but not always. And it's not always looking for A. Sometimes you might be looking for your O. So it's always depending on what the question is actually asking. So now we have our apothem. I want you to pause the video. Now actually find the whole area. And you should have gotten 618.3 centimeters. So if you look at this problem 2 now, it says you have a regular octagon. It has 8 sides. So this picture is representing this question. The standard size has a 16.2 radius. So that's this right here. That's this length right here. It's asking for what the area is. So before we can actually find the area, we have to figure out what the apothem is and what the side length is. So right now, I want you to focus on the apothem. I want you to look at this right triangle. So if I highlight what the right triangle looks like, this so far is what we have in the picture. I only want you to try to pause the video and find the apothem first. So you should have gotten that your apothem is equal to 14.97. The other thing that we have to figure out is what this x value is. So right now I want you to pause the video and try to find what x is equal to using SOHCAHTOA. So now you should have gotten that x is equal to 6.20. Notice how this third number was a 9, so that would move up. That would bump this up. Well, 9 bumped up, actually bumps up the 2. So when I say round to the nearest 10th, you should include that 0, showing me that you did round to the nearest 10th. But now again, my actual question is, what is the area of this? So my apothem we have 14.97. Now I have to find our perimeter. We have to be very careful with this question. We figured out what x is equal to. Now if I draw the picture or draw what we figured out for x, notice how, again, that's not the side length. There are 8 sides here. However, one side length is not equal to 6.2. One side length is half that distance. So I have to do 6.20 times 2. That will give me the whole side length. So this is equal to the side because the apothem cut that side in half. Now if I do that, I get the perimeter is equal to 99.2. So I have 1/2 times my side, or times my apothem, times my perimeter, right there. And I get 742.512, which gives me 742.51 units. There are no, oh, it says it up here, inch. So inches squared. We are going to do these questions right here in class tomorrow. So have a wonderful day.